All right, we're going to do 16 and 17. We need to first identify what type of equation it is. So looking at this equation, the x is squared, there is no y squared. So only one of the variables is squared, which means it is a parabola. And we need to write the equation in graphing form. So let's look at writing this in graphing form. We have x squared. I'm going to group the x's. Notice the 9 is already there, so we don't need to add any number there to have a perfect square. I'm going to move the 12y over to the other side. And to get this in graphing form, I now need to factor this. So this is x minus 3 quantity squared. And I need to isolate the y. So if I divide everything by negative 12, this gives me y equals, I want my a value to be written as a coefficient in front. So I'm going to write this as negative 1/12 x minus 3 squared. So here we have our equation. So y equals negative 1/12 x minus 3 quantity squared. In order to answer the remaining questions here, let's look at what they're asking for. So here we have a vertex. The vertex, the h value of the vertex is positive 3. The k is 0, because there's no number here. And in order to figure out the directrix and the focus, I'm going to actually sketch the graph. Because if we can sketch the graph, then it will be easier to determine those points. So we have a vertex at 3, 0. And looking at the equation, it's y equals, and this x is being squared, so this is a vertical parabola. But in order to figure out where the focus of the parabola is, I need to know what my p-value is. This number here is equal to 1 over 4p. If 1 over 4p is equal to negative 1 over 12, p would have to be equal to negative 3. So if my p-value is equal to negative 3, I need to count negative 3 from the vertex in the vertical direction. So this is where my focus will be, at the point 3, negative 3. The vertex is between the focus and the directrix, so I'm going to count positive 3 from the vertex to draw my line, my directrix line. That line ends up at y equals positive 3. And that's really all that's being asked here. If you wanted to sketch the parabola, it would be opening down. Now moving on to number 17, what type of graph is this? We have a positive 9 in front of the y squared, we have a negative 4 in front of the x squared. So coefficients have different signs, that means it's a hyperbola. So looking at changing this to graphing form, let's group the x's and group the y's. So the y's, 9y squared plus 18y. The x's get grouped. And I'm going to move that 43 over so that I can complete the square for the x's and the y's. So before we can complete the square, we need to factor out the a value here. So I'm going to take the 9 out. This becomes y squared plus 2y. And then I'm going to try to complete the square. For the x's, the a value is negative 4. Factor that out. And try to complete the square. I need to add 2 numbers over to the right side of the equation because I'm adding 2 numbers to the left side. So here, b divided by 2, squared, this is 1. And to complete the square here, b divided by 2 squared is 4. Over here, that means I need to add a 9 and a minus 16. All right, now we need to factor each of these. So 9y plus 1 squared minus 4x minus 2 squared equals, this side becomes 36. And then the only other thing we need to do to get this in graphing form is divide everything by 36 so that this side is equal to 1. So I'm going to write the simplified graphing form here. So this is y plus 1 squared divided by 4 minus x minus 2 squared divided by 9 equals 1. In order to complete this information here, let's look at our equation. So the center, the h value is the x value of the vertex, so that's positive 2, and the y value is negative 1. And in order to determine where my vertices are, again, just like I did with the parabola, I'm going to graph this just so I can visualize where the vertices of the hyperbola will end up. So my center is at positive 2, negative 1. And to sketch the hyperbola, I'm going to count 2 in the y direction, square root of this value here. 2 up, 2 down. And the square root of this value would give me 3, so 3 in the x direction, 3 in the x direction this way. So this is going to help me define the asymptotes of the hyperbola. So we have asymptotes here. And in order to decide where the curves of my hyperbola are, let's look at the equation. The y is the positive value, so that means it's a vertical hyperbola. The vertices of the hyperbola are these 2 points that the curve that I just drew are going through. So here we have positive 2, 1. And right here we have positive 2, negative 3.